So I'm going to go over explanations on how to answer the questions from the Chapter 4 quiz. So we're going to start with the multiple choice problem. So it says students at University X must be one of the class ranks, freshman, sophomore, junior, or senior. At University X, 35% of the students are freshmen and 30% are sophomores. If a student is selected at random, the probability that he or she is either a junior or senior is. So this one's just straightforward. If everyone has to be either a freshman, sophomore, junior, and senior, and we know how many of them are freshmen or sophomores, the remaining students have to be juniors or seniors. So what we want to do is 100 minus, and then we'll add the 35 and 30, which becomes 100 minus 65, which gives us 35%. We're going to use the following situation for problems 2 and 3. So in a particular game, a fair die is tossed. If the number of spots showing is either 4 or 5, you win $1. If the number of spots showing is 6, you win $4. And if the number of spots showing is 1, 2, or 3, you win nothing. And you're going to play the game twice. So one option here is to go ahead and create the table showing your outcomes. It's not a requirement, but it can help. So you can win $1, $4, or nothing. So you win $1 if you roll a 4 or 5, which there are 2, so the probability is 2 out of 6. If you get a 6, you win $4, so that's 1 out of 6. And then 1, 2, or 3 gets you nothing, so the probability is 3 out of 6. So our first question is the probability that you win $4 both times. So since the probability that you win $4 is 1/6, and you're doing it twice, you just do 1/6 times 1/6, which gives you 1/36. The next question says the probability that you win money. So you win money if you get a 4, a 5, or a 6. So if you win $1 or if you win $4. So 2/6 plus 1/6, which is 3/6, which is 0.5. Our next problem says that an event A will occur with probability 0.5, and event B will occur with probability 0.6. The probability that both A and B will occur is 0.1. So we want the conditional probability of A given B. So this is a formula given to you on your formula sheet, and it says the probability of A given B is the probability of A and B divided by the probability of B. And I give you all of these probabilities. So we know the probability of A and B is 0.1. The probability of B is 0.6. And 0.1 over 0.6 is just 1/6. The next problem says, if you buy one ticket in the Mathalicious lottery, then the probability that you will win a prize is 0.11. If you buy one ticket each month for 5 months, what is the probability that you will win at least one prize? So the best way to kind of think of this problem is to think of it as a binomial distribution, which it is. So if you think the probability notation is the probability that x is greater than or equal to 1. And when you're doing inequalities with the binomial distribution, if it's not already less than or equal to, you have to rewrite it as 1 minus. So the probability that x is greater than or equal to 1 is the same thing as 1 minus the probability that x is 0. Because the only thing, the remaining is just nothing. Because if you don't win at least once, that means you've lost all 5 times, basically. So if I do the binomial distribution for the probability that x is 0, that would be 5 choose 0 times 0.11 to the 0, and then times 1 minus 0.11 to the 5th, which basically just becomes 1 minus 0.89 to the 5th. Because 5 choose 0 is 1, and 0.11 to the 0 is also 1. So it just becomes 1 minus 0.89 to the 5th, which is 0.44. The next problem says, suppose that A and B are two independent events with the probability A equaling 0.2 and the probability of B equaling 0.4. So I want the probability of A and B. So if you have independent events, then we know that the probability of A and B is the probability of A times the probability of B. So that means I'm just going to do 0.2 times 0.4, and it's going to give us 0.08. Next, we're going to use the situation for problems 7 through 9. So we have a psychologist study the number of puzzles subjects were able to solve in a 5-minute period while listening to soothing music. X is the number of puzzles completed successfully by a subject, and it had the distribution. So they either solved 1, 2, 3, or 4, and then the probability. So the first question says, what's the probability that a randomly chosen subject completes at least 3 puzzles in the 5-minute period while listening to the soothing music? So that's the probability that X is greater than or equal to 3. And if you're given a table, you're just adding probabilities from the table. So that would be 0.3 plus 0.1, which gives us 0.4. The next question is, what's the probability that X is less than 3? So the only ones less than 3 are 1 and 2. So that's 0.2 plus 0.4, which is 0.6. And the last one asks us for the mean. So when you have a probability distribution and you're trying to find the mean, which is also known as the expected value, that's when you take the outcome and multiply it by its probability and add them all together. So we have to do 1 times 0.2 plus 2 times 0.4 plus 3 times 0.3 plus 4 times 0.1. And we end up with 2.3. All right, so now we're going to work on the free response or short answer. So we have that suppose for a group of consumers, the proportion that eats pretzels is 0.75 and the proportion that drinks Coke is 0.65. The proportion that eats pretzels and drinks Coke is 0.55, and we're going to have A be that a consumer eats pretzels and B is a consumer drinks Coke. So we want to draw a Venn diagram representing this information. So I do my 2 circles. Oh, terrible circle. Okay. So next I label my events, so A and B. One of the most important things to remember about a Venn diagram is you always start with the overlap. So we know the probability that someone drinks both is 0.55. So I'm 0.55 in the middle. When you go to fill out each of the remaining parts of the circle, you have to subtract the overlap from the total. So the 0.75 is everyone who eats pretzels, including the people who also drink Coke. So if you do 0.75 minus 0.55, and that will give us 0.20. And then we do the same thing for drinks Coke. So we do 0.65 minus 0.55, and that becomes 0.10. And then the last piece is the neither. And the neither is always on the outside. So the neither is whatever remains to get you to 100%. So 0.20 plus 0.55 plus 0.10 is 0.85, which means that my remaining probability would be 0.15. So my first question is, what proportion of people only eat pretzels? So that would be the only pretzel side, 0.20. The probability that a consumer doesn't eat pretzels or drink Coke, so that's the neither, 0.15. The last one says, what percent of people drink only Coke? So because it is a percent, we do want to write it as a percentage, so that would be 10%. Next, we have a table of information about adults in a metropolitan area and their political views. So we've broken it down by age and then the political view. So the first question is, what is the probability that a person chosen at random from the sample will have moderate political views? So that means we're going to look at the total of moderate. So the probability of moderate is going to equal 75 over 255. Now, I don't require that you simplify fractions that are this large. You can either leave it as that or you can give me a decimal, which in this case is 0.29141. The next question says, what is the probability that a person chosen at random from the sample will be 45 to 59 and have conservative political views? So the key word here is and. So that means we only care about the box 45 to 59 and conservative. So that's probability of 45 to 59 and conservative, which is 35 over 255, which if you convert to a decimal is 0.1373. The next one says, what is the probability that a person chosen at random from the sample will be over 60 or have liberal political views? So or means we care about the total from each of those rows, that row and column, so over 60, and then the liberal. But when we do an or, we have to remember to subtract the overlap, which in this case is 10. So the probability of over 60 or liberal is 45 over 255 plus 95 over 255 minus 10 over 255. And this is a formula given to you on your formula sheet. It's the general addition rule for probability, so it's not one that you have to memorize. So that becomes 130 over 255, which is 0.5098. The next one says, what is the probability that a person chosen at random from those in the sample who are between the ages of 30 and 44 will have moderate political views? So this one is saying that we were specifically looking for those in the sample who are between the ages of 30 and 44. So this is an example of conditional probability, so the given. So we're saying that given someone is 30 to 44, so we only care about the row of 30 to 44. Of those people, how many of them have moderate political views? So this time, our total is not the total from the table, it's the total from that row or column that we're looking at. So we say the probability that you have moderate given you are 30 to 44. So that's going to be 30 over 85, which becomes the decimal 0.3529. And the last problem says, based on your answers to A and D, are political views and age independent for the population of adults in this metropolitan area? Why or why not? So when you are doing independence, so we're going to have political views be my A and the age B. It is on your formula sheet. So two events are independent if the probability of A equals the probability of A given B. So for us, the political view that we're specifically looking at is moderate. So my A, probability of A, ends up being 0.2941. Probability of A given B, so the probability of moderate given your 30 to 44, was 0.3529. And those came directly from A and D that I already calculated. So because those probabilities are not equal, the two events are not independent. So we can say the two events are not independent. And then it's because 0.2941 does not equal 0.3529. So the next one says we have a distribution for the number of visits to a dentist in 1 year, so 0 through 4, and then the probability associated with that. So we're going to find probabilities based on this table. So the first one says the probability that x equals 4. So that one's straightforward, 0.05. The next one says the probability that x is less than or equal to 2. So that could be that probability that x is 0 plus the probability that x is 1 plus the probability that x is 2. So you're adding all of the ones less than or equal to 2. So 0.1 plus 0.3 plus 0.4, which is 0.8. And then the next one says the probability that x is greater than 1. So the ones that are greater than 1 are 2, and then 3, and 4. So I add all of those probabilities together. So 0.4 plus 0.15 plus 0.05, which is 0.6. The next one says E of x, which is another way to just say mean. So similar to the previous problem we did, the way you calculate your mean is to take the outcome and multiply it by its probability. So 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.15 and then plus 4 times 0.05, which gives us 1.75. So that's our expected number of visits to the dentist in 1 year. We would expect someone to go 1.75 times. Okay. The next one is the standard deviation. So now I'm not likely to ask you to calculate standard deviation on the quiz, mainly because even though it's not as time consuming as the standard deviation we're used to, it is still pretty time consuming. So it's not something that you have to memorize how to do, or even likely something I'm going to ask you to do, but I'm still going to show you how it's calculated. So when you do this standard deviation, you can do this all in one step under your calculator if you keep everything under the square root. Your other option is to do the part that's underneath the square root first, and then at the end take the square root of the number you get. Both will give you the same answer. So the way you do it is from each number outcome, you subtract the mean. So 0 minus 1.75. You square it, and then you multiply by its probability. And then you do that for every value. So then it becomes 1 minus 1.75 squared times 0.3, then plus 2 2 minus 1.75 squared times 0.4. Then 3 minus 1.75 squared times 0.15. And then lastly, 4 minus 1.75 squared times 0.05. Like I said, not something I'm likely to ask you to do on the quiz. So that's going to give us 0.9937. So that tells me that I can expect the number of visits to the dentist each year to vary by 0.9937. So the next problem says that the senior class is selling raffle tickets at the senior auction and dinner night. And we do mean senior as in senior in high school, not senior as in senior citizens. Each raffle ticket costs $10 and they plan on selling 200 raffle tickets. The prizes, which have been paid for from the money collected from the sale, are one $100 pair of headphones, two $75 TJ Maxx gift cards, four $30 Chipotle gift certificates, and 8 $15 AMC gift certificates. What is the expected value of a raffle ticket? And then how much profit per raffle ticket is the senior class expecting to make? So first I have to define my variable X. And my variable X here is going to be the winnings, or if you want to think about it in terms of the prizes that you can get from the raffle. All right. It is important when we're creating our table, we subtract the cost of the ticket from the prize value. So when I go to create my table, so my first prize is the $100 pair of headphones, which actually comes out to be a $90 prize. Then the $75 becomes $65, $30 becomes $20, the $15 becomes $5, and then the last thing I have to remember is I am not guaranteed to win a prize. They're selling 200 raffle tickets. There are not 200 prizes, so you could end up with just losing your $10. And then the probability is how many of those tickets would be winning. So 1 out of the 200 for the headphones, 2 out of 200 for TJ Maxx, 4 out of 200 for Chipotle, 8 out of 200 for AMC. Then that means the remaining are the losing tickets. So if I do 1 plus 2 plus 4 plus 8, I get 15. So that means 185 out of the 200 are losing tickets. So the expected value of a raffle ticket is just the mean. So my calculate it the exact same way I've done on all of the other examples. So 90 times 1 over 200 plus 65 times 2 over 200 plus 20 times 4 over 200 plus 5 times 8 over 200, and then plus negative 10 times 185 over 200. You can go ahead and just say minus 10 times 185 over 200. It is the exact same thing. It is up to you. So when I plug this in my calculator, we're going to get an expected value, and because it is money, it'll be a dollar sign, and it does end up being negative, so negative $7.55. So this is the expected value of a raffle ticket. So expected value of raffle ticket, negative $7.55, which is a good thing. You don't want the expected value of a raffle ticket to actually be a positive number, because that means that whoever is running the raffle ends up losing money. So in this case, it's a good thing that the raffle ticket has a negative expected value, because that means the senior class is actually going to end up making money off of the raffle. So that tells me the profit per raffle ticket is $7.55. The next question, it says that DACC has decided to create a committee of 12 students and teachers to discuss changes to make to the school dress code. There are 20 students and 10 teachers interested in joining the committee. So the first question says, how many different committees can be formed? So this is an example of a combination. So we have to first find the total people, which is 30. So of the 30 people interested in joining, only 12 of them are going to be on the committee. So we have to do all the different ways you can choose those 12 people. So 30C12. So remember, the formula is the n factorial, so 30 factorial, over r factorial, or k factorial, 12, and then n minus r factorial. So that becomes 30 factorial over 12 factorial times 18 factorial. And you can do this in a calculator. You are not required to show me all of the work for the factorial. So you end up with 8, 6, 4, 9, 3, 2, 2, 5. So remember, to get to the factorial, you just hit math, and then it will be right there at one of the first ones that you can choose from. You can also use the NCR in the calculator as well. So if you go to math, and then depending on your calculator, it's either PRB or PROB. And then number 3 is the NCR. You don't have to do the work for the factorial. I'm just doing it to show you how we got the answer. The next question is now the probabilities. So we want to know the probability that the committee will be made up of 10 students and 2 teachers. So my numerator is specific to this problem. So 10 students, and there are 20 students total. So we have to do 20 choose 10 times, and then the 2 teachers out of the 10 total, so 10 choose 2. And then my denominator is the 30 choose 12, because those are all of the possible combinations of people. So for my numerator, again, you can just do the calculator, but the way the factorial works, it'd be 20 factorial over 10 factorial, 10 factorial, times 10 factorial over 2 factorial, 8 factorial. And then my denominator is just the 8, 6, 4, 9, 3, 2, 2, 5. So it becomes 184,756 times 45 over my denominator, which gives me 8314020 over my denominator. And you can leave it as this fraction. You don't have to simplify it. You don't have to write a decimal. If you wanted to do the decimal, it's 0.0961. So almost 10% chance that it's 10 students and 2 teachers. The next probability is the probability that the committee will be made up of 8 students and 4 teachers. So now we're doing 20 choose 8 times 10 choose 4. And then our denominator is still the 30 choose 12. So we get 20 factorial over 8 factorial 12 factorial times 10 factorial over 4 factorial 6 factorial. And then the 8, 6, 4, 9, 3, 2, 2, 5. So we get 125,970 times 210. And then our denominator stays the same, which becomes 26453700 over 864932225. And again, you can leave it like that. You don't have to simplify it. The decimal is 0.3058. One reason, though, that I haven't been doing the decimal is sometimes these probabilities can be really, really small. So if you do it in the calculator, it might give you a number and at the end say E negative something, which means it's got a lot of zeros in front. So that's why I say just leave it as the fraction. That way you don't have to worry about getting a scientific notation as the answer in your calculator and then worrying about how to write it on the quiz. Okay. So the last problem is the binomial and geometric distributions. So the way I will ask this on the quiz is very similar to this question. I will just give you the scenario with the probability, and then you'll have to decide between each of the problems whether or not you have to use the binomial or the geometric formulas, which are given to you on your formula sheet. So we have Will fumbles, the only receiver for a high school football team with a likelihood of catching a pass of 0.15. The first question says, what is the probability that 2 passes are caught out of 6 passes? So this is an example of binomial. If you are trying to figure out the difference, when it comes to me asking a question, the biggest thing is going to be, are you given an n? If you're not given an n, then it's not going to be binomial. It's going to be geometric. If you're given an n, it's binomial. So that's the biggest thing you want to pay attention to. So we're doing the probability that 2 of them are caught. So that would be the probability that x is 2. So when we do our formula, we have to do n, which is 6, choose k, which is 2, times my probability of success, 0.15 squared, and then 1 minus 0.15, and then my exponent is 6 minus 2, which is 4. And then I just plug that into a calculator, and we get 0.1762. The next problem says, what is the probability that at most 1 pass is caught out of 6? So this is also binomial. And a key thing here is the word at most. So at most is going to tell me that I'm dealing with an inequality. So this is the probability that x is less than or equal to 1. Now, you could do this one separately. So the only number less than or equal to 1 are 0 and 1. So you could find the probability he catches 0 passes and 1 pass and add them together using the formula. You can also use binom CDF. So remember, binom CDF can only be used if it's already less than or equal to. And then you have your n, which is 6, then your probability, 0.15, and then your k, which in this case is 1. And we get 0.7765. The next one says, what is the probability that 2 or more passes are caught out of 6? So this is still binomial. In this case, because it says 2 or more, this tells me I'm still dealing with an inequality. So that's the probability that x is greater than or equal to 2. It didn't say more than 2, in which case it would just be greater than. It says 2 or more, so that means I want to include the 2. So when it's a greater than or equal to inequality, I have to change it to a 1 minus, because binom CDF only works for less than or equal to. So the remaining, if I want to find everything less than or equal to 2, so that's the same thing as doing 1 minus the probability that x is less than or equal to 1, which I already found. So I can go ahead and just do 1 minus 0.7765, which is 0.2235. But the way you would do it if it wasn't the inequality that you already found, you would do 1 minus and then binom CDF, and then you do 6, 0.15, 1. And then it would just give you the answer, 0.2235. But because I already found it, I'm not going to do it twice. Okay. So the next one says, what is the probability that the first pass caught is on the first attempt? So I no longer have an n here. So this is now going to change to geometric. So remember, geometric is saying that the first success happens on a specific trial. So this is the probability that the first success, so the first pass caught, is on the first attempt. Now this one you don't technically have to use the geometric formula to do. So this one is the probability that y is 1. So the beginning part of the geometric formula is your failures. So the probability he doesn't catch would be 1 minus 0.15. He's had 0 failures because we're saying success happens on the first attempt. So that just becomes point times then your success 0.15, which is 0.15. But if this had said the probability that the first pass caught is on the 4th attempt, then that would have meant that my first parenthesis would have been 1 minus 0.15 to the 3rd, because he's had 3 failures, and then times the 0.15. So it's always your number of failures first, and then your success. The next one says, what is the probability that the first pass is caught within the first 3 attempts? So this is again still geometric. And again, we're saying within the first 3, so that's going to be an inequality. So we're doing the probability that y is less than or equal to 3. So we can do geomet CDF here. And then you just need your probability and your trials. So it's going to be 0.15 and then comma 3, which is going to be 0.3859. 3 is small enough that if you wanted to do each one individually, you could. You could do the probability that it happens on the first, then the second, then the third, and add them all together. But again, you can just do geomet CDF. And then the next one says, what is the probability that it takes at least 2 attempts before the first pass is caught? So again, still geometric. And then because it says at least 2, another inequality. So this time it's the probability that y is greater than or equal to 2. Similar to a binomial distribution, geomet CDF only does less than or equal to. So I have to change this to a less than or equal to. So it becomes 1 minus the probability that y is less than or equal to 1. Now, for a geometric distribution, because it can never be 0, it has to start with 1 because we're talking about at least 1 success. This is the same thing as 1 minus the probability that y is 1. It's very specific to at least 2, though. If it were any other number, it wouldn't be the same. But I'm going to keep it as the GeoMet CDF. You can still do GeoMet CDF. It's going to give you the same answer. So then 0.15 comma 1, and you end up with 0.85. The last two are going to be examples of mean. So what is the expected number of catches with 6 attempts? So again, I've gone back to giving you an n. So this means I'm going to be doing the binomial distribution's mean. So the expected value for a binomial distribution, which is given to you on the formula sheet, is n, which in this case is 6, times p, which is 0.15. And we get 0.9. So that means we expect Will to catch 0.9 of the passes if he's get thrown 6 times, which is not great. And the last one says, what is the expected number of attempts before the first pass is caught? So this is the mean for a geometric distribution, which is again given to you on your formula sheet. So it's 1 over p, which is 0.15. So that becomes 6.67. And you are going to want to write the decimals for the expected values for binomial and geometric distributions. They are most likely going to be decimals, which is fine. They don't have to be whole numbers. They can be decimals, and you can leave them as decimals. So it makes sense, though, that the number of attempts has to be pretty much 7 or higher, because we saw the expected number of catches with 6 attempts was less than 1. So that kind of ties into my last question, where it's like how many attempts before there's a catch. They do kind of go together. So let me know if there's any other questions you have about the Chapter 4 quiz, or if there's any problems you want me to go into more detail on.